Hello, welcome to the continuation video of measurement, and today, or on this episode, we are actually going to be talking about dimension analysis in physics. And within a few minutes we should be done with this, because this is not a difficult topic at all. I just need to tell you what you need to know about dimension analysis and how to go about solving questions under dimension analysis. Dimension analysis is basically representing the base unit in physics with some letters, and that is breaking down a particular physical quantity, the unit of a particular physical quantity, in such a way that once you arrive at your base unit, represented with the following letters that I'm going to be giving you on the board. So once you arrive at your mass, you represent it with what? With a capital M. Once you arrive at length or distance or anything related to distance, you represent it with capital L. Once you arrive at time, you represent it what? With capital T. And once you arrive at temperature, you represent it with what? You represent it with theta or K, depending on which one you are comfortable with. And if it is an OBJ, an objective question, you have to check the options. If you see theta, that means you are going to work with theta, and if you see K, that simply means you are going to work with K. Now let us take few examples and arrive at the dimension, their dimensions, and see how it goes. So please take note of this: mass, capital M; length, capital L; time, capital T; and temperature, theta or K. Then one other thing that you should take note of under dimension is that all numbers, that is, let's say 1, 2, 3, 4, whatever, have a dimension of what? Of 1. They have a dimension of what? Of 1. Or logarithmic function, let's say, okay, maybe log, maybe 10, log 2 to log 215, log 15 base 2, and whatever, all have dimension of 1. All exponential function, all trigonometric function, and so on and so forth. Pi is also part of it. That means whenever you meet all these things in an equation, their dimension is usually what? Is usually unity, that is usually 1. So let us do a quick question under dimension analysis. I'm going to be writing out 3 questions on the board, and we're going to be looking or finding the dimension of them. Number 1, let's obtain the dimension for acceleration. Number 2, let us obtain the dimension of force. Then number 3, let us obtain the dimension of pressure, so that you can understand how to go about dimension analysis. So for the first one, acceleration, we have acceleration. There is need for you to know what? For you to know the formula of acceleration to effectively solve it. What is acceleration? Acceleration is simply the change in velocity per what? Per unit time. So I have my acceleration to be equal to what? Change in velocity over what? Over time, isn't it? So, and of course you also know that velocity is what? Is displacement over time. So velocity is displacement over what? Over time. And you know that we already have a time here initially, so that simply means I can say my acceleration is displacement over time. So what did I tell you about dimension? I said whenever you see anything that is related with distance, which is D, you represent with what? You represent with L, capital L. Then whenever you arrive at time, you represent what? With capital T. And I have 2 time at the denominator, that is time multiplied by time. So that means I have capital T multiplied by what? Capital T. So that simply means that I have my L over what? Over T square. So if I want to write it in a linear form, I'm going to have the dimension of acceleration to be what? To be L T minus 2. Simple. Now let us quickly find the dimension of what? Of force. So for the second one, I have what? I have force. Now what is force? force is actually equals to mass times acceleration. So my force equals to what? Mass times what? Times acceleration. Now, what is the dimension for mass? I said you represent it with what? With capital M. So that means I have a capital M here, multiplied by, we already have the dimension of acceleration here to be L over T squared. So that simply means that I have this to be L over what? Over T squared. So if I'm to write this linearly, that means my dimension for force will be M L T minus 2. As simple as that. So let us do for the last one, which is pressure. If I want to find the dimension of pressure, the first thing for you to do is know the formula for what? For pressure. Is know the formula for pressure. Now, what is pressure? Pressure is what? Is force per unit area. So pressure is what? Is force divided by area, force per unit area. Now, let me break this down so that it won't really confuse you. So I can write this as what? As force times 1 over area. Of course, definitely I have not committed any error. I just splitted the area so that you can understand what I want to analyze. Now, we already know the units, the dimension of force to be ml all over t squared. So I have this to be what? To be ml divided by what? Divided by t squared. Now, what is area? Area is what? Is length times breadth. Length is distance, breadth is also distance. So that means I have length times length. So my area is what? Is 1 all over what? All over L square. Is that taken? So of course this L, we cancel one of this L. So that means I have 1 L at the denominator. So that simply means that this will give me M divided by L T square. So if I'm to write it in a linear form, the dimension of my pressure is going to be what? It's going to be M L minus 1 T minus 2. ML minus 1 T minus 2. Now let me quickly also give the dimension of two quantities that usually gets physics students confused, and that is simply the dimension of gravitational constant G. Let us solve two more examples. The first example we are going to solve now is what? Is the dimension of gravitational constant G. And 2, we are going to find the dimension of what? Of what I call energy density. Energy density. So after solving these two dimensions, I'm just going to say one or two things, then I'll give you some drill to carry out. Now let us solve for the first one. For the first one, we want to find the dimension of what? Of gravitational constant G. Of course, you know that from Newton's law of universal gravitation, the force of attraction between two bodies is directly proportional to the product of their masses and inversely proportional to the square of the distance between them. It is also called the inverse square law. So from what I said just now, I said F is directly proportional to what? To M1 M2 over what? Over R square. So if I introduce my equal to sign, I'm going to have a constant of proportionality. So that means I have F equals to G M1 M2 divided by what? Divided by R square. So I asked you to actually find the dimension of gravitational constant G. So what you need to do is make G the subject of the formula from this equation. So that simply means that I have my G to be what? To be F R square divided by what? Divided by M1 M2. Now let me split it out well so that it will be clear. So I have F R square times what? Times 1 over M1 M2. Some of this we have actually solved it before. What is the dimension for force? The dimension for force is what? Is ML over what? Over T square. Now this R is actually the distance between them, and that represents length. So I said whenever you see distance for dimension, you represent it what? With a capital L. So that means for this I have L square multiplied by 1 over, now I have two masses here. Of course the dimension for mass is M. So since I have two masses, M times M is what? Is M squared. So that means I have M squared here. So looking at this, and this mass, we cancel one of this mass, and L times L squared will give you L cubed. So that simply means that I have L cubed divided by, we have one mass still remaining at the denominator, so that means I have M T squared. So if I want to write this linearly, I'm going to write M minus 1 L cubed T minus 2. This is the dimension of gravitational constant G. Then lastly, energy density. Should I leave that for you to try out? Okay, let me help you, because Made Easy Clinic videos by Pick Tutors is actually designed to help students demystify what they actually don't get in their classes in school. So let me quickly run through energy density. So the second one is what? Is energy density. Is energy density. What is energy density? Energy density is simply energy per unit volume. So that simply means that this is what the formula for energy density is: energy divided by what? Divided by volume. And take note that anywhere you see energy in physics, it is measured in what? It is measured in joules, and it is dimensionally equal to work done. That means I can replace energy with what? With work done, because it is dimensionally equal. So that simply means I can say that energy density is the same thing as me saying work done divided by what? Divided by volume. Now, what is work done? Work done is actually force times distance in the direction of the force. This is force times distance. And then volume, of course, is V. Volume is length times breadth times height. Let me replace that here. Volume is length times breadth times height. Now, let us break this thing down. So that simply means that I have force times distance multiplied by 1 over length times breadth times height. So what is the dimension for force? The dimension for force is ml all over t square. So I have ml over t square multiplied by what? Multiplied by distance. Distance is what? Is length. So you represent it with capital L. Times, now I have 1 over volume here. Length is length, breadth is also length, and height is also length. So represent it with what? With length times length times length, which is L cubed. So I have 1 divided by L cubed. So this simply means that I have this to be ml square divided by t square times 1 over L cubed. So that simply means that these two, we cancel 2 of these and it will remain 1. So I have m over L t square. So if I want to write it on a linear form, or in a linear form rather, I'm going to have what? I'm going to have m L minus 1 t minus 2. So with this basic analysis of what? Of analyzing dimension, we have come to the end of this video. Ensure that you carry out the examples or the questions that will be displayed on your screen immediately after the video, and do not forget to subscribe to our YouTube channel to obtain more videos from the Made Easy Clinic by Pick Tutors. I remain Bishop. Thank you very much.